DNA is said to be anti-parallel. The rails of the DNA are made out of alternating ribose and phosphate, ribose and phosphate, ribose and phosphate. The DNA is not symmetrical top to bottom, which is to say top to bottom is not the same as bottom to top. And if you turn it over, you don't have the same thing. The 5' to 3' on the one strand turns into a 3' to 5' on the other strand. The strands are backward relative to each other. DNA as anti-parallel refers to the ribose phosphate chain. It really doesn't have anything to do with the bases. Let's turn our attention to the bases. Adenine is a good example. Adenine, the molecule is flat. The molecule of adenine, the base, has no symmetry whatsoever. Left to right, top to bottom, front to back, there's no symmetry to it whatsoever. Adenine, of course, combines with 2 hydrogen bonds with thymine. And thymine has no symmetry. Adenine has no symmetry. The base pair, adenine and thymine, have no symmetry whatsoever. They're always combined the same way. Similarly, guanine combines with cytosine, this time with 3 base pairs. The guanine cytosine base pair, there's not a variation in how it can happen. The cytosine cannot be upside down. It's always right side up. It always makes the same base pair. So if we look at DNA as a spiral staircase, the stair steps are adenine, thymine, and guanine and cytosine. The stair steps are not, there's not variations in the structure of the stair steps. Let's turn our attention to this guy. This is a common drawing of DNA. I've looked at many of these, and they're all the same, which is to say none of them are wrong, or they're very consistent in the way they're drawn. Let's say we take the adenine. Let's have the adenine as the codon. Okay, so the adenine is the codon, and it fits right here. And then, of course, thymine is the anti-codon. Let's say we want to have the adenine as the anti-codon, which of course puts the thymine as the codon. So the strands are anti-parallel. So we turn this around and we find an adenine here, and we put the sugar on so it matches. So the strands are anti-parallel, but notice that the adenine doesn't fit. The adenine has to be turned back over in order to fit. So let's go back to these guys. We've got adenine, thymine, guanine, and cytosine. These guys, there's each one of them. Let's start with adenine, thymine. Adenine, thymine has let's make adenine the codon. We have 2 possibilities. We have this one, and then, I've drawn it, so this must be the top. No, this is not the top necessarily. This is just the way I've drawn it. It can also be like this. Okay, and then of course if adenine is the codon, thymine is the anti-codon. Okay, so let's make thymine the codon and adenine the anti-codon. Okay, what are the possibilities? Well, this time we have thymine is the codon and adenine is the anti-codon. But there's another possibility, and that is that this can be turned over this way. The top to bottom of business is something that we kind of make up as human beings. There isn't a lot of reality to that. So this looks like it's upside down, but it's upside down relative to how I've drawn it, but it's really not. I mean, what's upside down and what's not upside down? Okay, let's look at the guanine and the cytosine in the same way. We have guanine is the codon. So there's 2 possibilities. It can go like this. Guanine is the codon, or it can be upside down. guanine can be the codon and cytosine can be the anti-codon. And then, of course, the last one is cytosine, and then guanine is the anti-codon. And then, but it can be turned over. So every base has 4 possible orientations, which are too many, which is too many orientations. We only really want 2. Let's go back to this thing. Okay, we have guanine. Let's look at guanine as the anti-codon. So guanine is the anti-codon. Notice how it fits. Okay, we want to turn this over. Make the ribose make it the anti-codon. Look at the ribose. This is guanine. Notice the 3 hydrogen bonds. The guanine doesn't fit. If we turn it over, it does fit. And then finally, if we take this one is a thymine. This is an adenine thymine. So we have the adenine is the codon, and the thymine is the anti-codon. Okay, well, let's turn it over and find this is a thymine. Adenine thymine. If we put this guy on here, it doesn't work unless the base is turned over. So the conclusion seems to be that with thymine, for example, is the codon, the base has one orientation. With adenine as the codon, the base is turned over. To repeat with the other base pair, if cytosine is the codon, with guanine as the codon, the base is turned over. I have here representations of the base pairs. This is cytosine, guanine. This is adenine, thymine. These are representations of the base pairs. They have a front and a back, which is, of course, the same as a real base pair has a top and a bottom, which are different. These have a top and a bottom, which are different. We are wondering if with adenine as the codon, the base is not upside down if thymine is the codon. So let's kind of just move forward with this as an experiment. We're taking one, and let's use the codon on this side. Let's put adenine as the codon and put the black stripes up. Okay, we have thymine as a codon, but we're thinking that it's upside down, so let's go ahead and turn it over. So adenine is a black stripe up, and thymine is a black stripe down. Okay, we have a cytosine. Let's just put the cytosine on. We put the cytosine on. Okay, we have an adenine. Adenine we think is black stripe up, so let's go ahead and put the black stripe up for adenine. Okay, we have a guanine. Well, if cytosine is normal, then guanine is going to be black stripe up. So let's go ahead and put a guanine on. Okay, we have another guanine. Okay, cytosine is white stripe up, so put a guanine on. Okay, so what do we have here? Let's go ahead and take this guy off and take a look at it. We have like a representation of the stacked base pairs. Let's say we want to look down this side. We have 4 possibilities. We have red on the left and red on the right, and we have green on the left and green on the right. The cytosine-guanine base pair, it's always the same edge facing up, they're oriented differently. Like the symmetry is different. And then the other side is we have, these are all black, so it's a little bit harder to see, but there's still, again, there's 4 possibilities. There's a dot left and right and a stripe left and right for the cytosine guanine base pair and the adenine thymine base pair. There's two orientations for each one. The dogma of genetics is, of course, the RNA is transcribed against the anti-codon of the DNA, so that against the anti-codon, the RNA picks up the codon, which is kind of the idea. And then the RNA goes out into the cytoplasm and becomes translated into protein. So the codon of the DNA describes the amino acid sequence in the protein. But as important a question is, where does the RNA start and where does the RNA stop? What determines where the RNA does its thing? There are whole families of proteins that spend all their time in the major groove. They're inducers and transcription factors and repressors, and there are bunches and bunches of them. The transcription factors look at the edges of the bases and determine what's going on based upon feeling the edges of the bases. And the major groove looks at one set, and the minor groove looks at a completely different set. The major groove is bigger than the minor groove, and it would make sense that proteins which hang out in the major groove, which are most of these compounds, don't go into the minor groove. And that's it.